So this one says how much money will be in the CD at the end of 5 years. So the first thing we want to do is set up our formula here. So we can do P equals P naught, 1 plus, and we'll do the APR divided by the number of times that it's compounded, times the number of times times the number of years. And so we'll have P equals, our initial amount is 6,000. Then we'll up 1 plus, and then my rate is 2.9%, so 0.029. But I'm dividing that by 12, because I'm doing that monthly, times the number of months times T. And T is 5. And so if I compute that, one thing you'll need to remember when you're plugging this into your calculator is to put parentheses around the 12 times 5. And so if you compute that, you'll get $66,935.02. So that's part A. Part B says, what is the effective rate? And so what the meaning of that is it says that it's 2.9% compounded monthly. So the question is, what is the actual yearly rate? So it should be something close to 2.9%, but slightly larger. So what I'm going to do is I'm going to compute this part of the, function here. So I'll do 1 plus 0.029 over 12 to the 12. So I got 1.029. 388, so I'll do 39, and so the rate is round. It says round the percent to 2 decimals. So I need, so the rate then is, I'm going to look at this part of the decimal, and so it is 2.94% is the effective rate. All right, and number 9, it says sketch a graph of e to the x, identify domain range, and the asymptote. Okay. So if I graph e to the x, I know that e to the 0 is 1. So that point is one it goes through. I know that e to the first is e. And E is about 2.7. And I know that 1 over E, or E to the negative 1 is 1 over E. And 1 over E is about a little more than a half. So I can do that. It's going to look like this. I'll just put a few points on there. Okay, so what is the domain? The domain is all the possible x values that I can plug into e to the x. Well, I can put any number into e to the x. and it's defined. So the graph happens for all the x values. So the domain is negative infinity to infinity. And the range are all of the possible y values. So one thing you might notice is it never goes down to the y value 0, and it never goes below 0. So my range is 0 to infinity. And the asymptote, so it has this horizontal asymptote here. And the asymptote is at y equals 0. Okay, number 10, I have several different graphs of populations of towns. So I need to figure out which graph is which. Okay. And so basically what I want to do here is I want to think about, I need to put these in order. So I know that graph 4 has the greatest percentage increase. And graph 1 has the smallest. And another thing I'll notice here is that they have the same initial value. And if I look at these, I can see the initial value in front of all of these is a 1, right? So the initial value is 1 for all of them. So all I need to do is figure out what's the percentage increase for each of these functions, and then I've got it. Okay. So let me erase that, and then we'll do it. Okay. So if I look at e to the 0.3t, let's write that so if I have a of t equals e to the 0.3. So if I compute what e to the 0.3 is, that's 1.34. About 1.349. So I'm going to say 1.35. Whoops. 1.35. Okay, and what is b of t? Well, that's e to the 0.2t. And 0.2 is 1.22. About 1.221402 something. So like that. And c of t is 1.3 to the t. And d of t is 1.2 to the t. Whoops. To the t. Okay. And so if I want to put these in order, the smallest one would be the 1.2 inside. So D is graph 1. The next one is the 1.22 to the t. That's B. Okay. The next one is the 1.3 to the t. That's graph 3. And the next biggest is the 1.35 to the t, and that is graph 4. Okay. Then it says the population grows at a continuous 6% rate each year. What is its yearly percentage growth rate? Okay, so it's saying it's at a continuous 6%, so what it's wanting is the effective rate. So it's going to look like this. P equals P naught, e to the RT, which is P naught e to the 0.06 t. So let's figure out the effective rate. And it's going to be the same thing we did over here as we want to find out what is e to the 0.06. And I got, oops, what am I writing in blue? I got P naught times, and e to the 0.06 is 1.0618 to the t. And so if I look at this part of it, I can see that my rate of increase is 6.18%. So it should be close to 6%, but since it's continuous, it'll be slightly bigger. Okay, a radioactive substance decays at a continuous rate of 15% per day. There was initially 25 milligrams of the substance. Okay. Write a formula for the amount of substance present after t days. So A of t should be equal to my initial amount, which is 25. And then it's decaying at a continuous rate of 15% per day. So that's e to the 0.15 t. And the reason I'm using the e is because it says it's a continuous rate. So continuous rate, that means I'm going to use the e. All right, how much of the substance will be present after 4 days? So 25. So we'll do a of 4. Oops. Okay, let's plug that in. And again, you have to be careful here and make sure that you have all of that in your parentheses so that when you compute it, it raises that 0.15 and the 4 both up in the exponent. All right, so I got 45.55. And the units of that are what? Well, A stood for the amount of the substance present, and that's measured in milligrams. So that's how many milligrams of the substance are present. Then it's, oh wait, that doesn't make sense. It's supposed to decrease. Oh, so there's something wrong with my model. So it should be negative here. Negative. Okay, so let me plug that in again, and I'll fix it. Yeah, it says it's decaying, right? So you can't have more than you started with. That doesn't make sense. Okay, so let's try again. Okay, there we go. Now that looks better. So now I've got 13.72. Ah, yeah, that makes more sense. And again, it's still milligrams. Okay, then by what percentage does the substance decrease in 1 week? All right, so now T stands for the number of days, right? And so 1 week, that would be 7 days. Oh, I'm supposed to round to 4 decimals? Oh, round to 4 decimals. Okay. Yes, so we'll do A of 7 equals, by what percentage does the substance decrease in 1 week? So let's figure out how much is there in a week. So I get 8.74844. So that's how many milligrams are there, but that's not what it asked for. It asked for by what percentage does it decrease. So then I'm going to take the amount at day 7 divided by the amount at day 0 and see what we get. So the amount of day 7, that was 8.74844, and the amount initially was 25. And so I can compute that. And I got 0.3499. And so what that means, 0.34993, let's just get 37, so let's do 4. And so what that means is that's how much is left. So in other words, I have 34.9% left. But that didn't say how much to decrease. So I need to do 1 minus that, and then I've got it. So if I do 1 minus that, I get, so if I do 1 minus 0.349938, I get 0.650062. So that's 65.0062% is how much it decreased. Okay. All right, so in other words, let's go through all of that. So at after 7 days, I have this much left. To find out what percentage that is of the original amount, I divided them, and I got that was 34% of the amount that I started with. And so if I keep 34.9%, then that means I have lost 65%. So I just did 1 minus that to figure out how much went away. So if I have 35% left, that means I lost 65%. So that's what we did.